Hello everyone, in this video I will show you some basics about motors used in CNC machines. So these are all the motors I have. We have stepper motors from tiny ones to bigger ones. This is also the stepper motor, and we have also AC servos. These three over here are AC servos, and also this tiny one is a AC servo. Let's start with stepper motors, so let's get rid of the servos. Okay, so these ones are the stepper motors I have. You have tiny NEMA 9 motors, typical for 3D printers. NEMA 17 motor, NEMA 23, this is also NEMA 23, and this is NEMA 34. This type of motor I used in my plasma CNC plasma table, but with the encoder I will tell you more about this in a minute. These ones are typically used in pick and place machines because they are very tiny and the shaft is hollow, so the vacuum can go through the motor to the nozzle of the pick and place machine. These, as I said, are mostly for the printers or 3D printers or small machines. These are used with bigger CNCs. By bigger I mean the desktop ones. I typically use these motors. And this is an interesting motor because it's also a stepper motor, but as you can see on the label it says hybrid servo motor, which is not entirely true because it's stepper motor which has an encoder in this back compartment. Let's talk a little more about this one because it's very interesting one. As I said, it has an encoder in this back compartment. It's used to give a feedback of the rotor position. So when the motor is rotating, the encoder is monitoring this movement. So when the motor jams, it can detect whether it jammed, so the controller knows when the motor should spin, and if it doesn't, because the encoder told it, it reports an error. So these are way better than the typical stepper motors because these don't have an encoder over here. So if this motor jams, it just jams and the controller doesn't know it happened, so it just tries to spin the motor, but with no feedback it will just end up with some errors. This is how the encoder looks like in the stepper motor. Let me shine some light on it, and as you can see, this plate over here, the gray one, is the encoder plate. It has tiny blocks or ridges or something which is detected by all this electronics inside, and this is how the motor can tell, or the controller can tell, whether the motor moves or not. This is the optical encoder. The servo motors usually use magnetic encoders. The industrial ones most certainly will use the magnetic one, which is way better than the optical ones, but the cheaper ones probably use optical ones, as this one. Okay, so let's talk about the AC servo motors. These are all 4 servo motors. This is some cheap servo motor from AliExpress. I got, I don't know, for like 150 bucks or something like this. These are Bosch industrial servo motors, so pretty much no one used these for DIY CNC. I got them from my job for free because these are broken. Most certainly the broken are encoders, so the motors are fine, but the encoders are broken. And for my next machine I'll use this one for all the axes. The main difference between the stepper motors is the build of the motor. So what's inside? As I said, these are made by magnets, alternating magnets, and these have inside asynchronous AC motor. So it's basically just a motor and with the encoder. It doesn't have this stepping thingy, so it's just a motor, same as in your, let's say, ceiling fan or something. The same motor inside, just the three-phase one. These are all three-phase motors. This is the stepping motor, and it moves in a little steps. The main difference is the stepper motors are way weaker, so these are very powerful motors, and even this one is not as powerful. This is in 12 Newton meters, so this one is not as powerful as this one. This is just tiny motor. By power I don't mean the Newton meters, but I mean the output power. So this one, as you can see, is 0.4 kilowatts. So this is 400 watts, and this one will not output 400 watts. It will most likely just jam. So in conclusion, which one should you pick? This is very specific application of the motors because they are so tiny. If you're building a tiny machine or some weak axis like rotation axis or something like this, you can use this, but with anything that needs some power, this is pretty much useless. These are typical motors used in 3D printers, so 3D printers use such motors, maybe small machines, some small CNC machines, not very powerful. This is your good choice. I also have longer version, something like this. So if you want to build a CNC machine, go for the stepper motors. If it's your first build, go for the stepper motors. If you have a budget, go with the closed loop ones, so the hybrid ones with encoders. They are way better, so you don't have to worry about losing steps or other shenanigans. Then go with this one. This is way better. If you don't have a budget, go with the NEMA 23 motors, just typical stepper motors. They are also good, but not as good as these steppers with the encoder. If you feel a little fancy, go with the BLDC motors, but the drivers for these are way more complicated and usually require AC power for the operation. These usually don't. You have one power supply for all the motors, and this one motor requires individual driver with its own power supply, and these are out of the question because these are industrial ones. No one will put this in a DIY build. So yeah, that concludes our video. If you have any thoughts or questions or maybe ideas, hit me up in the comments. Let me know what you think, and thank you for watching.